Welcome to Brain Vision.
We have the diagram of the system, and we can say that for part A, the angular acceleration can be found from equation 10(9)c. And so we can say that omega squared would be equaling omega initial squared plus 2 alpha delta theta. And so alpha, the angular acceleration, would be equaling to the final angular velocity minus the initial angular velocity divided by 2 times the change in the angular displacement. And so this would, we know the initial angular velocity is 0. And so this would be equaling v over r quantity squared divided by 2 times delta theta. And so alpha would be equaling 26.5 meters per second divided by the radius of 1.20 meters, quantity squared, divided by 2 times delta theta, 8 pi radians. And we find that the angular acceleration is equaling 9.70 radians per second squared. Now, we can say for part B, to find the tangential acceleration, this would simply be equaling the angular acceleration times the radius r. And so this would be 9.702. We will round at the very end, radians per second squared multiplied by 1.20 meters. This is equaling 11.64 meters per second squared. And so we can say that the centripetal acceleration, or we can say for part C, the radial acceleration, would be equaling v squared over r. And so this would be 26.5 meters per second, quantity squared, divided by 1.20 meters. And this is equaling 585.2 meters per second squared. So these would be your answers for B and C. We can say for part D now, the net force is the mass times the net acceleration. So we can say force net would be equaling the mass times the net acceleration, and this would be equaling the mass times the square root of the tangential acceleration squared plus the radial acceleration squared. This would be equaling, we could say the net force would be equaling 7.30 kilograms multiplied by the square root of 11.64 meters per second quantity squared plus 585.2 meters per second quantity squared. And we find that the net force is equaling approximately 4,270 newtons. This would be our answer for part D. And then for part E, we're going to find the angle from the two acceleration vectors. So theta would be equaling the arctan of the tangential acceleration divided by the radial acceleration. And this is equaling arctan of 11.64 divided by 585.2. And we find that the angle is equaling 1.14 degrees. This would be our answer for part E. That is the end of the solution. Thank you for